Hello, this is Ryan, and this will be the demonstration of our greenhouse project. This dial simply here controls the contrast of the LCD display to display the values. This is the Arduino Uno R3 that controls the entire system. Here's a relay that controls the heat pads, and the MOSFET that controls power to the fan. The USB power to the Arduino is via a USB power bank, and the 12 volt supply is via a 120 volt converter to 12 volt DC. Now if I were to depress the lower temperature button, it would decrease the input temperature by 1 degree Celsius, which then turns on the fan to pull in ambient air temperature to decrease the enclosure temperature, assuming ambient temperature is lower than the enclosure temperature. Now that the temperature has reached the desired temperature, the fan is now off. Now if I were to increase the input temperature to say around 28 degrees Celsius, pressing the button 2 times, now that we are at room temperature, to increase the temperature inside the enclosure, I would simply press the button once to increase the temperature, which will then turn on the heat pads and pulse the fan to generate heat flow to transfer the radiated heat energy. The fan pulses from 4 seconds on to 30 seconds off. Now that the enclosure temperature has reached the desired temperature, the fan is now off and the heat pads are now off.
Okay, hi, I'm on Bray. I'm presenting part of our greenhouse project here for the CS2810 class. Apologize in advance. I've got some echo here with this screen recording, and just have to deal with it for now. So primarily I worked on a couple aspects of our project. I don't have it in front of me because we have the main project over at Ryan's house. Primarily I was in charge of the fan control, which if you notice here I've got a pulsing fan. This is just as a demo here to kind of show you. This is going to pulse at, I don't know, roughly 10% of the fan speed every 30 seconds for 3. We did this for a convection style heating. In our final project we had a heat sink type thing with some heat pads on it, and also for a cooling device. So initially I came about just trying to control the fan speed in general. There's a digital out way to do it, and there's also an analog right way to do it. I'm going to show you a quick snippet of, not that, let me open as a different user, quick snippet of some code. We ended up implementing this code in our final project, but I just wanted to show you it and discuss a couple of challenges I ran into. So initially I ran into some issues with regards to this key feature here, delay, which is kind of like a sleep method in, I don't know, many other scripting languages, except for the fact that this halts all additional program calls at all. So if you do a delay 20 seconds per se, this is 3, that'll halt any other calls or whatever. So it's not like exactly a traditional sleep, and that gave us some problems with trying to get the Arduino to check temperature and other things at the same time. So I ran into, after some research, a couple of examples using this key function millis, which looks to run based off of the program counter. And I say that maybe not in the literal sense with the MIPS program counter, but in the fact that it starts when your program starts. There's no way to reset it, so you have to overload it. You have to not overload it, but account for rolling it over by setting the current time to now, basically, or subtracting the previous time to make up the difference. This workaround worked pretty well, and it seems to be what is industry standard, what is widely used in the Arduino IDE side. So we did that. We don't have to wait for any other delay except for the 3 seconds, which is nice. We could have gone with another if-else statement, maybe like some sort of bool that says, yeah, this has been hit. But the problem we're running into is it's easier to hit the first if statement if we have a longer interval to wait, versus we have to do a 3-second on, 30-second off kind of a thing. So this ended up just being the easier way to do it. At first I ran into a couple issues attempting to use a relay as a switch for on-off in this situation, and I burned out a couple of small relays, or not relays, transistors as relays. I burned out a couple transistors, and eventually landed on a video with this dude using MOSFETs for the same thing. So here's the MOSFET I end up using, which is a 1030 something IRF 530N. 3 pins here. This one's the gate. This one's going to go to the middle one's going to go to your negative on the fan, and this is the source from negative. Other than that, it's pretty straightforward. I did some assembly with Ryan at his house on the box. We ended up using a couple of different heating pads that didn't initially heat like we thought it would. I burned out pin 10 on this Arduino. I accidentally touched it to negative, and pin 10 doesn't work anymore. Yeah, so that's about what I have for my input here. We initially had some different ideas going into this project, but settled on the greenhouse after some discussion. So it was fun. I learned a lot. Comparatively to MIPS, obviously this Arduino IDE is a lot easier to code with. Found it almost too easy as far as the coding is concerned. Anyways, that's my input for this project, and all I can think about while I'm on the spot right now.
Hello, this is Ryan, and I will be going over some of the lessons I've learned throughout this term project. Basically, I was the hardware guy, so I had a lot of the components to mess around with. But during some testing, I noticed that I noticed some of the LEDs blew up because of the drive voltage being too high, as LEDs only require a small voltage, probably about 1 to 3 volts compared to some of the 9-volt inputs and 12-volt inputs of the circuit. And when I was just testing the LED in place of a heat pad circuit, LED just blew up. And messing around with Arduinos has also taught me that sometimes it can be tricky with multiple data streams, but with the temperature sensor that we use, it only has a refresh rate of about 2.5 seconds to 3 seconds. So if I increase the refresh time, the LCD would not display the correct value. It would always just jump to like certain extremes of the temperature. But if you give it some time, then it works fine. Also, the Arduino code is relatively easy, such that it doesn't require a lot of skill, as there are a lot of tutorials out there that give you examples and such, which really helped me throughout the project, as I never messed around with Arduino before, so I was able to learn some of the language background of Arduino, which can be very useful in my other classes that I'm going to take. Also, throughout this project, I learned that it can be a little tricky by having members only program certain portions, but without any hardware to test, it's kind of hard to see if the result match the code that is intended to perform, because I've written some of the Arduino code, but it didn't really match what I wanted in performance wise, and if I didn't have the hardware, I wouldn't have noticed that at all. So having the hardware really helps with Arduinos. And I think that's about it. Thanks.
Hey, this is Scott Kuehl-Shelby with the Greenhousemon project. Just going to walk through the greenhouse control code real quick. So up at the top here, this whole first section, we're defining mostly in-out pins for various things. For the LCD, got several right here. And then for the buttons used to increase or decrease the desired interior temperature. Also got some global state variables in there used to store whether the button should be increasing or decreasing temperature. So in the Arduino setup section, then we take all of those pin variables that were declared further up and actually do the initialization for real down there. And then I'm going to skip down into the main loop of the program. So each iteration, we just update the LCD screen and then figure out if we should be trying to increase, decrease the temperature, or keep the temperature the same. And depending on which one of those we're trying to do, we're going to either supply power to the heating pads, to the fan, or to neither. And in the event that we are supplying power to the heating pads, we're going to also be pulsing the fan in 4-second intervals. And so then that's all that's going on in the main loop there. And then to actually handle user input, we have 2 interrupts, one for each button, that are going to detect if the user pressed the increase temperature button, decrease temperature button, or has pressed both buttons at the same time, which is the signal to reset to the default temperature of 27 degrees Celsius. And that's pretty much it. Just loop through and send power to either heat it up or cool it down or do nothing, and then get interrupted when the user presses a button.